Good day everybody. In this video we'll learn how to read geological maps, and we'll look at two maps. The first one is shown here. So this map from one of our studies on landslides, and you will see here that we have lots of different colors here. Gray, a little bit purple, yellow. So you will see that the color will represent the type of rocks or soil. And if you don't know which exactly it is, so we can look at the legend. So this is important part, and this is called legend. So legend gives you explanation on the color, and it shows what deposit, either soil or rock, belongs to each color. Another important thing about this map is the scale, because we would like to know the distance from this point to this point. To know that, we're going to use the scale, and scale in this case is given as 1 kilometer. So this much on the map will give you 1 kilometer in real life in that area. So sometimes you will see that there are maps, the scale goes like 1 over 250,000. Sometimes there is maps 1 over 25,000. So how do we read this one? So the easiest way to read this map, and the way that I do, is I just remove 2 zeros at the, from the right end, and it will give me scale 1 centimeter. It's equal to, in the first case, it will be 2,500 meters. So it's this one. And in the second case, it's going to be 1 centimeter, equal to 250 meters. Why do we have different scales? It actually depends on what kind of investigation we would like to do. For larger areas, for general maps, we typically have a larger scale like this. So this is to cover larger areas. For some specific sites, when we do a detailed investigation, we would like to have more precise map with a scale, like for example like this one, 1 centimeter, 250 meters. Okay, let's see what else do we have here on this map. So this map was about landslides, and you will see this is location of landslides. There have been lots of landslides in that area, and some of them just triggered by rainfall. So another thing, it shows north and south. There is one important part that is missing, and which doesn't make this map very valuable. And if you look at the map, you will see that there is different types of rock and soil on the surface, but we don't know what material is underneath the surface. So if we go like maybe 10 meters deep or 20 meters deep, we don't know what is in there. So the part that this map is missing is called cross-section. Cross-section would show you the location of different soil and rock layers underneath the surface. And this is what good geological map should always come up with. And now let's look at the second map. So the second map, it's some area. To be honest, I don't know where the area is, but we're just going to look at the map and see what is presented in here. So again, you will see that it has different colors, and these different colors, green, yellow, blue, they're all explained in the legend. So it says explanation. Some people call it legend. So you see there's explanation about the color. It represents a different geological units, mostly in this case rock units. We have different rocks right on the surface. Another thing that is important, it's faults. So typically they're shown on such geological maps as a line, and it's going to be a red line like you see one red line here. So this is the fault, this is another fault. Faults are very important, especially when we do site investigation. We need to identify these faults, because faults typically create very fractured and weathered rock, and typically faults are associated with some soil movements as well. So that's not really good engineering foundation, the faults. Also it shows some bearing planes, strikes in deep. If you don't know what bearing planes means, please watch my video on bearing planes. And it also given a scale. This much, I don't know if we probably measure it will be 1 centimeter. We need to use a ruler. It will be equal to 1 kilometer. And also very important part, it's cross-section, and this is how cross-section looks like. So it typically presented underneath the geological map, and this cross-section is drawn for this line A dash here. So I will have another video how to draw cross-section. I just want to explain that cross-section will show you the material underneath the surface. So typically for cross-section we need to drill a few boreholes, and all the data about geology underneath the surface comes from those boreholes. So you will see that when we look at the cross-section, what is underneath the surface up to 1000 meters deep. So this is 1000 meters. We have a very good understanding about the type of rocks that are present and how they are placed against each other. You will see that we have layers of different rocks, and they're deep at some angle, steep angle. So here we also see there is this fault goes in this direction. We see lots of bearing planes of this green material here. So this gives us lots of important information about geology of that area, and it will help us better understand what can happen if we construct any buildings on top of the surface, what can happen if there is any water, if water is seeping underneath the surface in some weathered rocks. So this gives lots of information. Well, that's it what I wanted to talk about geological maps. I hope you now have a better understanding how to use geological map. Thanks for watching. Bye.